Welcome back to the deep dive. You've probably seen those sci-fi movies where artificial intelligence, turns into a terrifying villain, right?
Oh, absolutely.
It makes you wonder if that's where we're headed. But then on the flip side, there's the AI you use every day.
Kind of like Alexa, Siri.
Exactly. Even the suggestions popping up on your social media feed, it's this wild mix of incredible potential and maybe for some, a little bit of unease.
It really is. And it's easy to get lost in the hype or, the Hollywood versions. But the reality of AI is, well, far more grounded, but still totally revolutionary in how it's already impacting our world.
So today, our mission for this deep dive is to kind of cut through all that noise. We're going to really dig into artificial intelligence, what it fundamentally is, how it actually works, and why it's suddenly such a massive deal right
Now
now.
let's unpack it.
We've gone through the material you shared to get to the core concepts, making it clear and hopefully understandable without dumbing down the really cool parts.
Right. This isn't about, sci-fi doom scenarios. It's about understanding a powerful tool that's already reshaping industries and, honestly, our daily lives. We'll look at the brains behind it, the practical helpers that get things done.
The agents, you mean?
Exactly, the agents, and even how these systems learn from their own mistakes to get smarter.
Okay, so if we hear AI all the time, let's start right there. What is artificial intelligence at its most basic level, like boiling it down?
Okay. At its core, AI is basically when a machine or computer can show intelligence. That means learning new things, making smart decisions, solving problems, kind of like a human brain does.
But wait, you might think computers have always been smart. They do math way faster than me.
And that's true. A regular computer can blast through calculations.
But here's the crucial difference, right? Those traditional computers are just following the exact instructions we program into them. They're like super fast calculators.
Exactly. They only do what they're told. What makes AI different is its ability to do something new, something it wasn't specifically taught step by step.
Mm.
It learns on its own, mostly by finding patterns in huge amounts of data.
So it's not just following orders, it's figuring things out.
Right. Think of AI itself as just raw brain power, like a super genius buzzing with ideas, all this potential.
Okay, so if AI is this raw potential, this ability to learn, how does it actually do anything? How does that potential turn into action?
That's where the AI agent comes in. If AI is the brains, the agent is the one that, rolls up its sleeves and gets things done.
The doer.
The doer, exactly. It takes that raw intelligence and turns it into actual concrete actions to handle specific tasks.
That makes sense. It's like the difference between knowing how to bake a cake and actually baking it. So these agents, they have a process.
Yep, usually a pretty clear flow. First, they need to understand what you're asking or needing. Could be a voice command, typed text, right input. Then, they think they process that information using the AI model, figuring out the best way to respond or help.
Processing?
And finally, they act. They deliver what you need. Maybe it's an answer. Maybe it's performing a task like booking something or changing a setting.
Action. Understand, think, act. Simple enough.
But how do they get good at that?
Yeah.
How are they trained? Think of it like leaving instructions for a babysitter.
Okay.
You give them the rules.
Yeah.
Right. Bedtime. What snacks are okay? What to do if there's an emergency. You don't script every single word they'll say.
Right. You give them guidelines and context.
Exactly. That's how AI agents are trained. Developers feed them detailed instructions, usually embedded within massive data sets, guiding them on how to respond in different scenarios. Some might have basic preset rules, others are highly customized for specific jobs.
So what we see is the user. That's just the tip of the iceberg.
Pretty much. You see the interface, maybe a chat window, a voice assistant icon, a button.
Like talking to my phone.
Right. But behind that is the workflow. It's a series of automated steps, sometimes called nodes, that the agent follows. It's generally that four-step cycle we mentioned. Input from you,
My command.
then processing, the AI thinking bit, running calculations based on its training, then the action, doing something, and woven through all that is learning. It subtly adjusts, getting a tiny bit smarter with each interaction.
And that's why these agents are being called such a huge deal, a seismic shift, because they automate stuff.
Largely, yes. They can handle so many routine, predictable tasks. This frees up people, us humans, to focus on more complex things, growth, creativity, strategy, innovation.
So for businesses, that could mean what? Smarter customer service bots, more efficient internal processes.
All of that, or entirely new ways to offer services. It allows humans to step away from the repetitive stuff and into more strategic thinking roles.
Okay, this learning part is key. How does AI actually learn? It's not magic, you said.
Definitely not magic. It's a process. And the bird identification example is a great way to picture it.
Let's do it. So imagine we want an AI to tell us if a picture has a bird in it.
Right. We start by defining some general features like 2 legs, wings, feathers, a beak. And maybe we give each feature a weight, like how important it is for being a bird.
Okay, like feathers are probably pretty important.
Probably gets a high weight. Then we show it pictures. If it sees a robin or a crow, classic bird features, it adds up the weights, scores high, maybe 100%, and says, yep, that's a bird.
Easy enough. But what about tricky cases?
Good question. What if we showed a penguin? Based on its initial rules, maybe the wings look wrong or the feathers aren't typical. It might score low and say, nope, not a bird.
But a penguin is a bird.
Exactly. So this is the crucial step. We correct the AI. We tell it, no, that is a bird. And when it gets that correction,
It learns.
it adjusts those internal weights. It might learn that, okay, maybe feathers aren't a perfect predictor, or maybe wings can look different ways,
Yeah.
or perhaps an 80% match on features is still definitely a bird.
So it tweaks its own rules based on feedback.
Precisely. This constant refinement of these internal weights, which is kind of the core idea in things called neural networks, trying to mimic brain connection. That's how it learns. See thousands of examples, get thousands of corrections. Eventually, it gets really good at identifying any bird, even types it's never seen before. That whole process, that's training.
Wow. Okay, so from that bird example, what are the big takeaways?
Okay, 3 key things. First, AI doesn't understand birds like you or I do. It's not thinking, oh, that flies or that sings.
It's just numbers.
It's just numbers and patterns. For the AI, a bird is a specific combination of feature scores and weight values. It recognizes the pattern, not the concept in a human sense.
Okay, point 1, no real understanding. What's 2?
Second, it needs tons of data and human help, like thousands, maybe millions of bird pictures for a really good model.
Yeah.
And critically, humans have to label that data and correct mistakes. Learning doesn't happen in a vacuum. It needs that feedback loop.
Got it. Lots of data, lots of correction. And third,
Each AI is usually very specialized. The bird spotting AI. It can't suddenly do your taxes or identify cats.
it's a one-trick pony.
Pretty much. A new job usually means a whole new AI program and completely new training, often starting from scratch.
Okay, that clarifies a lot. But if the ideas of AI have been around for decades, in labs and movies, why is it suddenly everywhere now? What flipped the switch?
Great question. 2 huge reasons, really. The first one is just raw computing power.
Faster computers.
Much faster. Computers back in the, say, 1990s, they just couldn't handle the sheer number of calculations needed for complex AI. But over the last 20 years or so, processing speed has exploded thousands of times faster. That finally made powerful AI practical on a large scale.
Okay, makes sense. We needed the muscle. What's reason 2?
The second one, social media and the internet explosion.
How does Facebook help AI?
Well, think about it. Every time you tag your friend or your dog in a photo,
You're labeling data.
you're labeling data for free. You're teaching an AI, this is what a dog looks like. This is what a human face looks like. Multiply that by billions of photos, messages, comments, even the slang we use.
So it's not just pictures, it's language too.
Exactly. All that methy, real-world human language from social media gave AI massive amounts of training data to understand how we actually talk and write, not just dictionary definitions. That's a huge reason why things like chatbots got so much better.
Wow. So faster chips and basically us feeding the machine data constantly?
That's a big part of it. And all this power and data has led to some amazing new types of AI, especially generative AI.
Right. I've heard that term, generative. It generates things.
Exactly. It can create new content, stuff that didn't exist before. Texts, images, music, even computer code or voices.
How does that work? Do you just ask it?
Pretty much. You give it a prompt. That's just you describing what you wanted to create, usually in a chat box.
Okay, so examples.
Well, ChatGPT and Google Gemini are big ones for text. You ask a question, they generate an answer. Delhi is famous for images.
Delhi. I've seen those crazy pictures.
Yeah. You could ask it something like, show me a photo of an astronaut riding a horse on the moon. And it will generate that image from scratch based on your text prompt.
That's wild. Is it always accurate, though?
That's the catch. Generative AI can sometimes hallucinate.
Hallucinate. Like it sees things.
Not quite. It means it can generate answers that sound totally plausible, really confident, but are actually incorrect or just made up.
Oh, right. So it can be confidently wrong.
Very confidently wrong sometimes.
Yeah.
The quality really depends on the data it was trained on, and honestly, how good and clear your prompt is. Garbage in, garbage out still applies.
Okay. So moving beyond the cool stuff and the movie hype, what are the real, genuine concerns about AI we should be thinking about?
That's important. One big one is the black box problem.
Black box.
Like, you don't know
What's inside?
Exactly. Especially with very complex AI trained on massive data sets. Even the creators often don't fully understand how the AI reaches a specific decision or conclusion. Its internal logic becomes opaque.
You gave that wolf example earlier.
Right. The AI learning to identify wolves, but it wasn't looking at the wolf, it was looking for snow in the background, because most wolf training pictures had snow.
So it found a shortcut, but the wrong one.
Exactly. And if you don't know why it's making mistakes or even why it's succeeding, it's really hard to fix problems or even trust its outputs reliably, especially for important decisions.
Yeah, like in medicine or finance, you
No.
need to know why.
Precisely. This is driving a lot of research into explainable AI or XAI, trying to build systems where we can understand the reasoning.
Okay, black box problem. What else?
Bias in data is another huge one. AI learns from the data we feed it.
And if the data is biased,
So the AI learns that bias. The classic example is AI used for hiring that started favoring male candidates. Why? Because the historical hiring data it learned from showed mostly men being hired for that role in the past.
so it just amplified existing human bias.
Exactly. Our own societal biases, even unintentional ones, get baked right into the AI models if we're not incredibly careful about cleaning and checking the training data for fairness.
That's a big responsibility. Anything else major?
Deepfakes are definitely a growing concern.
Those fake videos.
Yeah. This often involves multiple AIs working together. One AI, the generator, creates the fake video or audio, maybe swapping someone's face onto another video. Then another AI, the discriminator, tries to spot the fake.
Like a quality checker.
Sort of, yeah. It pushes the generator to get better and better at making fakes that are harder to detect. They learn from each other, making the final results scarily realistic sometimes.
And the worry there is misinformation, fraud.
Absolutely. Spreading false information, impersonation, undermining trust, it's a serious challenge.
So summing up the risks, it's not really about AI waking up and deciding to be evil, like in the movies.
Not based on the AI we have today, no. AI doesn't have feelings or consciousness or desires. It's just executing complex instructions based on patterns. The real danger is humans misusing this powerful tool.
Using it for bad purposes.
Right. Influence campaigns, scams, discrimination. The tool itself is neutral, but how it's used by people is where the risks lie. It puts the onus on us for responsible development and deployment.
Okay, let's try to categorize AI a bit. You mentioned different types based on their job.
Yeah, we can group them by function. There's natural language processing, or NLP. That's AI focused on understanding and using human language.
Like Alexa and Siri understanding my commands.
Exactly. Then there's generative AI, which we talked about the creators.
ChatGPT, Dello.
Right,
Yeah.
and computer vision AI, which deals with understanding images and videos, facial recognition, object detection in self-driving cars, that sort of thing.
Okay, NLP, generative computer vision.
Oh.
And what about classifying them by how smart they are, their capability?
Good distinction. Here we usually talk about 3 levels. First is weak AI, also called narrow AI.
Weak. Doesn't sound impressive.
Huh. The name's a bit misleading. It just means it's highly specialized. This is basically all the AI we have today. It's designed to do one specific task extremely well.
Like playing chess, or identifying birds, or translating.
Perfect examples. Brilliant at its one job, but can't do anything else.
Okay, so that's weak or narrow AI. What's next?
Next is strong AI, sometimes called artificial general intelligence, or AGI. That's still theoretical.
The sci-fi stuff.
Getting closer.
Right.
AGI would have human-like general intelligence. It could learn, understand, and apply knowledge across a wide range of tasks, adapt to new situations. Basically, think flexibly like a person.
Does it exist?
Nope, not yet. Most experts think true AGI is still decades away, if it's even possible. There's a lot of debate.
Okay, theoretical. And the last one.
The final, purely speculative level is super AI, or artificial superintelligence, ASI.
Even smarter than humans.
Way smarter. Intelligence surpassing human capabilities in virtually every field. Science, creativity, social skills, everything. This is the AI you often see in movies that becomes godlike or turns against humanity.
That's pure speculation right now.
Absolutely. Purely speculative. Not something we have or are even close to having.
So bringing it back to the real world and those movie fears, the consensus among experts is that AI is suddenly becoming conscious and evil.
Yeah.
that's not a realistic concern for now.
For now, yes. Today's AI, even the most advanced, doesn't have consciousness, self-awareness, emotions, or personal motivations like power.
Yeah.
It's just incredibly complex pattern matching and instruction following.
Which brings us to another big question people have. Jobs. Will AI take all our jobs?
It's a valid concern, and AI will definitely change the job market. But history shows that major technological shifts like electricity, computers, didn't just eliminate jobs overall.
They changed them and created new ones.
Exactly. Some tasks get automated, yes. But new roles emerge, often focused on working with the new technology. So maybe AI won't take your specific job, but someone who learns how to use AI tools effectively in your field might become more competitive.
So the key is adapting, learning to work with AI.
That seems to be the most likely path forward. Leveraging AI as a tool to enhance human capabilities rather than seeing it purely as a replacement.
Wow, okay, we've covered a lot of ground here.
We really have.
We started with the basics, what AI actually is, that ability to learn from data. Then we talked about AI agents as the doers.
Right, turning that intelligence into action. And we dove into how AI learns using that bird example, adjusting its internal weights through training and feedback.
Then generative AI, the creators, like ChatGPT and DALL-E and the weirdness of hallucinations.
And the real world challenges the black box problem, making sure we tackle bias in data and the issue of deepfakes.
Plus, we clarified the different types of weak AI that we have now versus the theoretical strong and super AI from fiction.
It's a complex picture,
Well,
but hopefully a bit clearer now.
Definitely. And it feels like this is truly just the beginning, doesn't it? AI agents, these helpers, they seem poised to become woven into everything.
I think so. Making tasks easier, hopefully freeing us up, creating possibilities we haven't even thought of yet.
So maybe a final thought for you, our listener, to chew on. As AI continues to develop, what new kinds of tasks will you want an AI agent to handle for you in the future? And looking ahead, what kind of entirely new, exciting jobs might pop up as we learn to work more closely alongside these increasingly capable machines?